is because we just did it. So only get down what you need to get down. I'm never going to ask you for what is the definition of a chemical formula. If you already know that it shows you the atoms of what's in there and then how much is in it, like H2O, if you already knew that that meant 2 hydrogens and an oxygen, there's nothing you need to write down for this. Right? That's all this says. Is chemical formulas are the symbols of the elements and the amount of each one. Right? That's all it is. And there's lots of stuff out there that are represented this way. Everything that's inside of you can be represented in like a chemical formula. The stuff you drink, like sugar, it's a chemical formula. You might even know the chemical formula for sugar. For regular old glucose, if you remember it from like photosynthesis or whatever when you did that. That's the chemical formula for sugar, C6H12O6. We'll deal with ionic bonds, and that'll get us through here. So gaining and sharing electrons. Nothing to write down here at all, just using your periodic table based on what you know. How many electrons does potassium have in its outer shell?
4.
Nope. Yep. Should be K. Should be 1, right? And then iodine, I think, is number 53. If you find iodine, how many does that have in its outer shell? So it's going to be the same situation as sodium and chlorine before, right? When these things bond together. When they combine, the potassium loses an electron and gives it to iodine, which gives potassium a full layer, gives iodine a full layer, and they become full and stable. They become potassium iodide. And then, last question, which one of those becomes positive, potassium or iodine? Nope.
Potassium.
Yeah. It's the one with a positive 1 over it. Which one becomes negative? Iodine. It's got a negative 1 over it, so it becomes negative. It's as simple as that. Yes? We're going to go over that. I don't know if we're going to get to it in the time we've got today. We should. So I'll probably be able to answer that question for you today. So, first thing, vocab word, big one that we're guaranteed to go over is ionic bond. And when atoms transfer electrons, when they move them back and forth to become stable, they can form these things that are called ionic bonds. A definition for the ionic bond is that it is the attractive force between the opposite charges, right? You've got one that becomes a positive and one that becomes a negative, and they attract each other like a magnet. And that's what causes an ionic bond. The positive gets attracted to the negative. Those two atoms get locked together, and they are then ionically bonded together. You want to put it on there. But to name compounds, you got to know the oxidation number. You don't need to write this down, but this is how we're going to do it. The oxidation number, you know those positive 1, 2, 3, 4, negative 3, 2, 1 that we wrote across the top? Those are the oxidation numbers. So if you've got those on your periodic table, you're golden. If you don't have those on there, at some point you are 100% going to need those on there, or it's not that hard to memorize. You just memorize positive 1, 2, 3, 4, negative 3, 2, 1, and then you got it. So either write them or have them memorized. So that oxidation number is just a cheat, is all it is. It tells you, without having to think about it, how many electrons an element's got to lose or gain to be stable. It tells you what its charge is going to be afterwards. That's all it does. So next come the steps. Much of the stuff that we kind of do in here, particularly with bonding, for some people, it'll click like immediately, and it's like, oh my gosh, this is so easy. For some people, it's not going to click so easy, and you're going to think, oh my gosh, this is so hard. But eventually, for whatever reason, and I don't know why it happens this way, but I guarantee it for all of you, eventually you'll think, I got it, and oh my gosh, this is so easy. Like it will, I guarantee you it will click. If it doesn't click right away, just have faith in me that after 11 years of doing this, I've seen it happen every single time. If it doesn't work for you right away, I guarantee you it will click in place for you. And some people, after a while, you don't even need to follow these steps. You can just see how it works out. So we're about to go over the steps here of how you write out the formulas. So the first thing you do, like when you write a formula like NaCl, it is never written ClNa. It's always NaCl. And that's because the positive one always comes first. The one with a positive oxidation number over it, like positive 1, 2, 3, that one always comes first, every single time. So the first thing you do is you write the symbol of the positive one. For example, can you guys find an element on your periodic table that has a positive number associated with it? All right, I heard magnesium. So magnesium is always going to come first. It's positive. If you get one that has like magnesium and sodium, those are two positives, and that doesn't work. That's either I've made a mistake or somebody's trying to trick you. But you have to have a positive and a negative to make this work. So you always write the symbol of the positive one first. If that's true, what do you figure the second step is? Negative 1 second. So if you can look on your periodic table and find one that's a negative for me. All right. So positive 1 first, negative 1 second. And I'm just writing these up here for my own reference. But magnesium is a +2, right? And nitrogen's a -3. Okay, I'm just writing those up there for me. You don't need that. That's just so I don't have to think about it every time. So far so good. Positive 1 first, negative 1 second. Perfect. On to the next step. It's a math step. Do you know what lowest common multiple is?
Yes.
Okay. So lowest common multiple, or LCM, is the lowest number, or smallest number, two numbers multiplied to. As in, like, lowest common multiple for the number 3 and the number 4. What's the lowest number that they can both multiply to? No, that would be divide to. 12, right? Yeah. Because 3 times 2 is 6, but 4 times nothing is 6. 3 times 3 is 9, but 4 times nothing is 9. 3 times 4 is 12, and 4 times 3 is 12. So that's the lowest common multiple. It's the lowest number that they can both multiply to. The next step you got to do is you need to find the lowest common multiple of the numbers up here, of the oxidation numbers. You don't have to worry about positive and negative anymore. The only time that mattered was when you set them up here with the positive 1 first and the negative 1 second. So now those positives and negatives don't matter a bit. And if I asked you to find the lowest common multiple, the lowest number that 2 and 3 both multiply to, you would say 6, right? So I write it out because it makes my life easier. LCM equals 6 for us there. And now we're going to figure out how you get the numbers down below. So to get the numbers down below, here's what you do. You take the lowest common multiple, which is 6, and divide it by its oxidation number, and that's the number you're going to write down below. So what's 6 divided by 2? 3. So it would be Mg3. And then what's 6 divided by 3? 2. Mg3 and 2. That's how you do it. That's how you get those formulas done and taken care of. A little bit tricky, right? You probably need a little practice with it. And that's just fine, because that's what we can do right now. So as soon as you got this done, like working out your notes,